Alright, so today we're going to be talking about properties of trapezoids and kites. So we've got our trapezoids and our kites. And with that, we're going to have some different notes that we'll fill out and try to tie all this stuff together. But I want you to take a look at these vocab words up here. Put a little star by the ones you don't know. And then after you go through those and you're like, I don't really know what that means, I want you to read through the theorems on the bottom of page 217. That may help you with a few of the definitions. And then the theorems on 218. There are a few of them there. Okay? Make any notes you need for that. Off you go. All right, go ahead and tell your neighbor which of those 6 theorems was the one that you really had no idea of, or you learned something about. You learned something from.
I figured out type once I saw it, but I didn't know it first.
Okay, how many are talking right now about Isosceles trapezoid base angles theorem? Okay, how about the Isosceles trapezoid base angles theorem converse? Okay, what's the converse? Yeah. When you're trying to prove a quadrilateral is an isosceles trapezoid, that's when you'd use the converse. Just like what Maddie said about parallelograms up there, right? Good job, Maddie. Okay, and isosceles trapezoid diagonal theorem. Who said that one? Okay, how about mid-segment theorem? That's usually the one that gets most of us. Yes, mid-segment theorem. The mid-segment going from midpoint to midpoint is half of the sum of the two bases. So if we add this base AB to DC, take half of it, you get this length. And they're parallel. How about the diagonals for kites? Another one that crosses at a right angle, right? Okay, and then opposite angles theorem. Okay, well here's what I want you to do. I'm going to be passing out something that's kind of going to summarize everything we've dealt with in quadrilaterals for this chapter. Okay, but while I'm doing that, I want you to take a look at that diagram right there. This is page 402 out of your textbook if you want to make a note of it, or if you want to make a copy of it later, or if you want to draw that copy. Those are all the quadrilaterals we've studied this chapter. Okay, and I just want you to look at how they all go together there, kind of in a flow chart. Okay, make any notes you need. Okay, so notice the most specific name that a parallelogram can get is called a square. That's when you kind of marry a rhombus and a rectangle, you end up with that square there. You have a trapezoid, but when you get these base angles congruent and legs congruent, you get an isosceles trapezoid. And then kites have adjacent sides congruent. And non-opposite sides are not congruent. That is a kite. Okay? So really you look at quadrilateral and then you start specifying and getting really specific about it from there. Okay? Any questions there? Alright, so what I want you to do is take a look at the chart that I just gave you. Try to do it without looking at your notes. Just put an X for what property applies to each of those that we've studied. See if you can remember. It's a good summary. Use a pencil just in case you have to erase. And compare with your neighbors. See if you guys match up now. All sides congruent? Opposite sides congruent? Yes? Okay, opposite sides parallel. How about here? Opposite angles congruent. All right angles? No. Diagonals bisect each other. In a parallelogram? Yeah. Okay, diagonals congruent. Not always. Diagonals perpendicular? No. Diagonals bisect opposite angles? No. Base angles congruent? Nope. Okay, that would mean the two bottom angles. Only one diagonal bisects an opposite angle. Nope. Only one set of opposite sides, or angles, opposite angles congruent. No. Okay, now some of these we're more specific to a rhombus and a square. So as we go through this, let's get a little more specific. All sides congruent. Is that true for a rhombus? How about a square? Or a rectangle, excuse me. No, square? Okay, how about these two? What do these two, or excuse me, what do these four things have in common? They're all parallelograms, right? These two are not. So any property that you see for parallelogram will automatically apply to those others. They have to because they're parallelograms. It's just we get more specific as we go across now. So are all right angles? Well, that happens in a rectangle and a square. Doesn't necessarily happen in a rhombus. There is a rhombus that it doesn't have right angles. Diagonals are congruent. That happens in a rectangle, and a square is also a rectangle, so it happens there. Okay? Diagonals are perpendicular. They cross at right angles. It happens in a rhombus and in a square because they're the same, but it also happens in a kite. Yeah. Okay. Do any of these other things, by the way, happen in a kite or an isosceles trapezoid? Diagonals bisect each other. Diagonals are congruent in a what? Isosceles trapezoid. Do diagonals bisect each other in any of those? No. Yeah, Moonty? Opposite sides congruent in isosceles trapezoid? No, they have one set, the legs are congruent. Yeah. So not both sets of opposite sides, but one set, yeah. So I think, well, we'll get down to that. Diagonals bisect opposite angles. Okay, what does that happen in? A rhombus and square, because a square is a rhombus. Base angles are congruent. That happens in a? Yeah. Only one diagonal bisects opposite angles. That happens in a kite, and that's it's if we're looking at, let me show you a kite here. Okay, this is number 7 on page 219, but that happens in this diagonal. Okay. All right, only one set of opposite angles congruent. That is a It is a kite. Is it in isosceles trapezoid though? There is one set of angles congruent, right? Here and here. But are they opposites? No, they're not opposites. So in a kite though, these two. Right? Okay. Any others we need to fill in there? Did anyone have all that?
Almost.
You're close?
So,
Pretty good summary. So wait.
For the base angles congruent, since the base angles are congruent in a rectangle and a square,
In a rectangle and a square, are the base angles congruent? What do you guys think? I mean, here's a rectangle, right? This box. Is that angle congruent to that angle? Yeah, man. Good. Anything else we've missed? Base angles are congruent for rectangle and square. Good job. No, but good job. You get a good job. That attaboy. Attaboy. Attacarla. All right.
Mr. Not a boy.
Fine. All right. Hey, good summary of your learning right there. Okay, what I'd like you to do is take a look at page 219. On page 219, we're going to spend about, 10 minutes or so on that. 5 to 10 minutes. Check it here in a minute. I'm going to hand out some of your assignments, or your assignments that we're going to work on today afterwards. So let's kind of go through those there. Hey.
What date did it take the online test?
For you?
Yeah.
just come in before school at lunch. What lunch do you have?
I have eggs.
Okay, so before school. What time do you get here? We can do it next Monday. Too. Okay. All right, Rocker Monster, turn down your music. If you have to have it that loud to hear it, then we've got some problems, dude.
Apparently it's not that loud, but the reason is because there's a speaker on the side of the actual headphone instead of inside your ear, which is really weird that they did that.
That is weird. I'd throw those headphones away.
Yeah, I use a different one.
Okay, decide whether the trapezoid is isosceles, then find the lengths. Well, there we've got it. If it's isosceles, we know that these lengths of our legs are congruent. Are they congruent? Turn that off. Because I can hear. And more specifically, because I said so, but that's ridiculous. You can ask me.
I said what?
Oh, okay. That's because you couldn't hear. All right. Slope of QT is the same as slope of SR. How do we know? Well, they both have a slope of 1. So therefore, you have a trapezoid. Since the base sides are congruent, it's an isosceles trapezoid. Okay. You can actually go through and figure out the lengths. Hopefully, we wouldn't have to do that. And find the length of the mid-segment. Well, the mid-segment's the tougher one, right? So that means you'd have to find the midpoint of this side and the midpoint of this side. Or find the length of this side and the length of this side. And then divide by 2. Okay? So if I'm finding that's probably the easiest way. Find the length of QT. Pretty cute. Okay? And find the length of RS. And then divide them by 2. Everyone know how to do that in a quick way using the Pythagorean theorem? Is that what you're doing? Yeah, you could take the distance formula. But you guys, the Pythagorean theorem is kind of like the distance formula, right? If I was to take this, like if I already have something graphed, I'm just quickly got my triangle there, and I'm going through and I'm saying, okay, this side right here is 3, so the square of that is 9. This side's 3, so the square of that is 9. That means this a squared plus b squared is 18, and the square root of that is that length. That's root 18. Everyone see how I did that? Okay, so I do the same thing with a triangle here, right? A right triangle. Okay. So look at this side. What's this length? 6. And 6 squared is 36. And this length? And this. And so this is 30, root 72. So root 18 and root 72, all divided by 2, is the length of the midsegment. That's our midsegment length. It's really hard to write there. Sorry.
Is that what you write down? Or do you...
No, we'd have to actually calculate that, right? We have to simplify. Root 18 becomes what? Root 9 and root 2, which is 3 root 2. And root 72. What perfect square goes into 72? Ah, 64 doesn't go into it. Cut it in half. What do you get? Root 36 by root 2. So that gives me 6 root 2. How many root 2's do I have? How many root 2's? That's disturbing. I've got 6 here, I've got 3 here, I've got 9 root 2's over 2. Okay? That is my length. If you wanted to actually do the math on it, and calculate it out, 6.36-ish. Okay. So make sure you write up your explanation on why it's an isosceles trapezoid. Talking about your slopes and the length of the legs, and then calculate the length of the midsegment. Okay. Any questions on that one? bit difficult, yeah. Moonsy, question?
For the theorem for the trapezoid mid-segment, it says that for each base, the length is 1/2, so couldn't you just find one length is...
You'd have to find both lengths and add them up to find. It's half of both lengths added together, the sum of the lengths. Yeah, that's why we're doing that. Okay. Okay. Hey, I want everyone to try numbers 2 and 3. Okay. Okay. Tell your neighbor what you got. Okay, number 2, 23, 157. Okay. All right. Remember, these have to add up to 180 because they're supplementary angles. Okay. How about number 3? Yeah. Yeah, 70 and 70. Both are 70. Good. They're congruent. Questions on 2 and 3. All right. Give number 4 and 5 a go. Find CD. All right. What's CD? Yeah, 12 plus 36 divided by 2 is 24. And yeah, here we have 0.6. So we have 1.8. We got to double that. That's 3.6. And 0.6 from 3.6 gives us 3.0. Dude, version 3.0 right there. 3.0. All right. Any questions on those? Last two, 6 and 7. Go ahead and tell your neighbor what you got there. Number 6, x equals 9. And we got to add this to that, divide by 2. Okay, and that'll equal your 3x minus 2. What do we get for number 7? 91? 100? Anyone? Anyone else? Who said? Okay. Let's try that one. So we know that this is congruent to that. Okay, so we set it up. We move our 1 over by adding 1. You just subtract 1 maybe. Okay. Multiply by 10. Okay, any questions?